Hello, everybody, and good morning and good afternoon, depending on where you are on the planet. And it's my pleasure to welcome you to this Sparring Partners on the decomposable AI landscape. If you are noticed, and I know that many of you are repeat guests in the Sparring Partners, I've been doing a lot of Sparring Partners on AI and automation, and this is because this is part of an upcoming report. And what that means is that we're digging deeper and deeper into all the fascinating parts of this. There is a lot of hype, there is a lot of interest, and there is a lot of promise that comes from AI and automation. And as we talked also in the previous ones, which I'm going to send you a link so that you can see them as well. The interesting part is that there is so much to unpack. And so there is a lot of promise, but also there's not oftentimes much in a way of clarity of information, which is always the case because it's a new thing. We're all learning. But some people are a little bit ahead of the rest of us because they've been doing it for a long time. And this is the case of my two guests today, who have been working on it from different angles for quite some time, and we will hear from them. And the topic today is the decomposable AI landscape. So how do we break it apart? How do we make sure that all the parts work together? Now, as the moderator, maybe I need my AI assistant here. I already forgot the important thing, which is the housekeeping items. So this is the Sparring Partners. It's not a webinar, so it's a conversation where we all talk to each other, and we love to hear from you as we go along. So do ask questions, and you can ask questions in the Q&A, and that way we see them, but the other people in the audience do not, or just chat away in the chat window, and this way you can send not only questions but also your comments. You can tell us what you think about what we say. Do you agree? You don't agree? Whatever, feel free to interact in the chat. In the chat, if you send anything to anybody, make sure that whatever you send is nice and respectful of everybody on the Sparring Partners audience and speakers. And we do not do a Q&A at the end. So the sooner you ask your questions, the more likely you are to have it answered, and we'll try to weave it in our conversation. So do ask questions as soon as you can. As soon as you have them that pop up in your mind, write them down, and we'll get to them, I promise. Said that, let's go back to the topic of our conversation today. So as I said, the reason why we're calling it the decomposable AI landscape, and we will go into that later, is because the question is, okay, you have AI, you have automation, you have a network, you have data. How do you pull it all together in a way that is efficient? Because the problem is that you might have all the AI, and this is true for pretty much anything else, right? You can have all the tools you want to have it, but if you don't deploy them right, they might become an overhead rather than helping you. They are going to create a problem. How do we, how do we deal with that? And so, as I said, I'm happy today to have two speakers, and Per has been on Sparring Partners before, and Takai has been on the Sparring Partners on a background before, because they've been working from different angles, one more from research and development, and the other from the customer side. But they've been working on this for quite some time. So we're going to be able to rely on their experience to see what is that we can do. Okay, said that. Let me let them introduce themselves to you so that you get some context, and then we'll go with the conversation. And as I said, your questions. Fair. Okay, let me, today I'm not very good at this. So let me formally introduce the speakers today. It's Per Kangru, Business Development and Strategy CSO at VIAVI Solutions, and Takai Eddine Kennouche, the AI Data Modeling Architect at the CTO office at VIAVI Solutions as well. So welcome, Per, welcome Takai, and may I ask Per to introduce yourself?
Yes, very well. So my name is Per Kangru, as you said, and I'm working. I'm based in Sweden. I'm working globally and trying to see how we in VIAVI can really figure out where the world is heading, how that world is evolving, and then with that evolution, where does that take us? Where do we position ourselves? I started working with a number of partners in, for example, the evolution of the Etsy CSM work a couple of years ago, and from that we obviously have a strong foundation of AI in that, and able to drive changes through that. So from that, I've been deeply involved in looking at what we can or should achieve, and then what is possible as well, and what is achievable, and then trying to weed out what is, how should I put it, good and realistic use cases that are actually going to deliver real substantial value for customers versus things that is just hype and not reality.
That's pretty ambitious. You want to see where the world is going. Okay, we'll take you on that. Takai, how about you?
Yeah, so thanks, Monica. So yeah, I am the AI specialist at the CTO office. I'm the other face of the coin to what Per just said. I do a lot of research, do a lot of development as well. I try to look at VIAVI's position and its strengths in the market and our product portfolio and legacy, and try to see what AI/ML makes sense for us to adopt and in which manner, so they can assist our customers in their journey for full automation, right, and reducing costs and increasing efficiency of their networks. Yep.
Yeah, thanks. And okay, why don't we start exactly right there, which is, this is something that, whenever you work on something, it's always great to see that everybody talks about it. But at some point it becomes kind of like, are we just talking too much about it? Is there too much hype that our expectations are so high that it's just going to be counterproductive? Where do you think we are in this path?
Yeah, it's very interesting. Yeah, that's indeed the elephant in the room, and we started right there. So yeah, there's definitely a lot of hype, and I'm not the only one who would make that such an observation. I think we are probably at the peak of this hype, especially around the Gen AI use and its disruptive potential across the industry. So I think it comes a lot, maybe in many parts, from maybe misunderstanding of what these technologies are intrinsically made of and capable of doing. It also comes from a desire. I think it's a genuine desire for various industry players to progress and make some progress in this journey towards automation. I mean, AI has been in perpetual hype cycles, right, for a long time, and every new paradigm or technique comes in, and people are all excited. Well, finally, I'm going to automate fully my network. Finally, my network is going to reach full autonomy, and it's self-organizing and it's self-optimizing, et cetera, et cetera. And and I get disillusioned every single time, and I don't think this is going to be different. But the good news is at every one of these cycles, we end up with certain elements of reusable notions and techniques that we just keep augmenting our arsenal, and I think that's probably going to happen. We're gonna have yet another fascinating new AI/ML paradigm and technique, but ultimately it's gonna have to fit a larger and a more fundamental, more let's say pragmatic approach of how to actually build solutions that can actually gradually increase level of automation, not necessarily immediately having generic all-knowing AI that gives us autonomy, right? So I mean, this is more or less how I think about it, but there is definitely a lot of moving parts to this hype as well. Yeah.
Yeah, and I think the pragmatic part, I think it's really important, because a lot of the discussion is just so high level, and it's like, yeah, it's good, but what exactly? And maybe probably you can tell us, so Okay, AI can do all sorts of things, but what is that we need? What is it you hear from customers? What is it they need? What do they need it for?
Well, I mean, AI help to do certain things that we humans are not very good at. So to do things repetitive 1,000 times, most humans get bored and start making mistakes. If we ask a human to analyze 10,000 network clusters and then analyze them and come up with recommendations around it, it will be boring, it will be unproductive, and it will not be a sort of good use of human labor. But for an AI, that's a task that is very easy and relatively straightforward in means of how can I then analyze those, how can I create clusters of those, and then obviously you need a human to help to decide, now when I know these clusters, how do I make the clusters better? How do I take care of this? So we're going to use AI to help to do certain things where humans inherently are not very good at in doing them at volume, but humans can do them maybe at 1 or 2 or 5 of them, but not 10,000. And then secondly, AI can help us see patterns in things where those patterns might be too complicated for human to easily see and identify. And we are as well speaking about something that is, from a sort of literature point of view, was described in the sort of end of 90s as the silent intellectual capital. So the silent intellectual capital is what takes someone with 20, 30, 40 years of work experience in something, why they can solve a problem in 5 minutes, and someone else who's a good skilled individual takes hours or days or weeks to solve the same problem. And that silent intellectual capital, AI is reasonably good at being able to instantiate once you have trained it on a set of data. So those are things where if you start looking at what is it that have made people with a certain set of experience and decades of experience being extremely productive, and we can start to replicate some of that productivity through what AI can do and what AI can help with.
Yeah, absolutely. And I think that, you're putting your finger in a very important thing. There are some things that humans are not good at, and we should acknowledge that. There are some things that we're just not good at it, but others that are very good at it. So what AI allows us to do is to focus on what we're good at and ditch what we're not good at. Like, have the machine do, it's like when you're cleaning your home, you have Roomba doing the stuff that, we don't really want to do, and it's kind of boring. But then we do the things like we pick furniture, we do whatever we do at home. So that I think is really important to keep in mind. It's not us versus, it's not AI versus human. It's how to get them to work, how to get us to work well with. And this is actually the topic of the last Sparring Partners, or the role of humans in all this.
Yeah.
But so Takai, so you come from a research background, which is, I think it's really important because this is all new stuff and we're all learning. So this is very important. What do you see that, in order to, again, to get real tools, to get AI to really work, what is that it takes? What is that we need to specifically do here?
Well, I guess for all intents and purposes, I think most of the time when we talk these days about AI, we're talking about data-driven systems, right? And they have proven themselves, and we do have a lot of evidence of them delivering value in various situations. And in the data-driven systems, I think you definitely start with data, right? So that's a foundational element to get in the system, to get in whatever AI system-based use case you're interested in to work. So you need data. Now, not only that you need data at a certain, at a good quality, so quality assurance when it comes to provisioning and acquiring, data is extremely important. You need systems that can deliver this data reliably. So when it comes to telecommunication networks, this is extremely important given the scale that our telecommunication networks have reached. So delivering the right modalities of data from a customer throughout network elements down to locations where you need to train our machine learning models is extremely important. But then not only the data, the other face of the coin is the models themselves, right? So yeah, and that's about talent, and that's about expertise, and that's about knowing from all of the possibilities that the research in the AI/ML are giving us, what paradigms and what techniques have proven themselves to be reliably generalizable, reliably implementable. Evaluation metrics here are key. Data sets used to create these, if in the case we're interested in pre-trained models, data sets to create these, are they enough, for example, to generalize use cases beyond their training environments, for example? So this is extremely important, especially in the telecommunication industry, where it's not very often that you see research work that has been exposed to large-scale, realistic telecommunication data. So this is extremely important to be aware of.
Yes.
In other areas of AI/ML, you might have that luxury, right? That in your research environments, you might have millions of image data. You just scroll from the web and you can just train your models, right? And you process them in all manners. But for the telecom, for research at some universities, to access millions of records from subscribers, that's rarely possible, to be honest. So acknowledging this and that this is a challenge, that there are ways to remedy this. And I think we are going into a process in the telecommunication industry right now to try to remedy this. Consortiums are being formed, and 3GPP is having discussions around this topic. ORAN and all of this 6G driving AI is kind of triggering these discussions again, that the importance of data for the telecom industry. So yeah, so basically, in summary, this is it. There is data on one hand, how to provision it and make it available, and then modeling and proven models that can actually deliver at scale at an acceptable cost. And together, that's how you can build a good foundation to build AI/ML systems. Yeah.
Yeah,
I see, Per, you were nodding there,
yeah.
But maybe
Yeah,
you probably have a lot here to say as well.
I think Per is itching. Go ahead, Per.
Yeah. So the thing here is that at a certain point right now, everyone is doing various things, and some of the funding for these projects comes from what I would say special project money inside operators, comes from the CTO, it comes from CSIO, and it comes from others inside the organizations. And it means that those individual projects don't necessarily have to have a robust immediate ROI. But once you start to productize these things inside operators as things are going to continue to operate going forward, you start looking at the fundamental costs involved of maintaining a well-trained model with good hygiene, with good explainability and good other things. Then at that point, you're seeing that this is going to build a structural cost. And as an organization, you can probably manage one of those. But if you find yourself having 5 separate AI environments, with 5 separate models that separately needs to be trained on likely very similar data sets and other things, then you start to rack up the costs. And when you start looking at this is where you're coming into the question of, how do I rationalize this? Do I select only one set of use cases? Or, as what we are proposing and discussing here, and what we are seeing going forward, can we basically find a good model where you get reusable components, reusable capabilities, and that is where we end up with that, what we sort of coin as the decomposable AI landscape. Can we get to a point where we are able to provide certain fundamental services? Those services can then be reused by a multitude of use cases, probably by a number of companies, both from external third-party vendors and as well operator internal or customer internal use cases. But they all fundamentally is based upon reusable models with a strong level of both security, transparency, and observability on those things, and then with a good and strong understanding of how you maintain and manage those going forward. And if you then find yourself that you actually want to replace one of those models, you can actually do that without sort of doing it 5 times. But you can come up with and say, well, this new model is much better for us. It's much more efficient in training or other things, or it's much better for our business value. And you can replace that at one place rather than 5, if you end up saying that this is a better one. So net, when the industry is leaving the worst hype curve, there is a need for rationalization. People don't build AI use cases just because they are AI use cases. They build them for they are the right things to do. And at that point, how should I put it? You need to sober up and be ready to face, the real realities and the real costs. And at that point, you need to be ready. Yep. And we think it's time for that discussion today.
Yep. Yes, it really is time. And this is actually a part that it's new in a sense that's it's a concept that is not entirely new. I mean,
Yeah.
to be able to reuse elements, it's not new. But it's new in the context of AI and the whole idea of composable AI. It's a new one. So I would like a little bit of time exploring that. So my first question would be, how does the decomposable AI approach fit into the ecosystem? Because obviously, we're going to have networks that are more open. You have more vendors. Everybody's going to do his own AI thing. And how is that working?
So do you want to take that, Takai?
I'm going to start from this perspective. I think we cannot avoid the reality that we will be deploying AI more and more, and I think we will be deploying a lot of it than we did in the past. We have maturing ecosystems. The open source ecosystem of AI is taking the world by storm. So there is a lot of accumulated experience in the recent years that we can definitely leverage to deliver some good value to the teleco customers, right? Now, what does that mean? That means that at any given network, for it to fulfill its automation needs or scalability needs, intelligence needs, optimization, etc., we are bound to operate in a multi kind of ML provider ecosystem. Multiple third parties will come with pre-trained capabilities and trained with different data sets, data sources in different locations and different training paradigms, etc. But then they all have to exist. So there is this ages-old question of interoperability across multiple ecosystems. It's just that here now it impacts directly complex data-driven operations, right? So these are questions of how to make sure that this can be deployed reliably, nicely fit together, and then deliver the actual business value, where the business value might be dependent on 2, 3, or 4 orchestrated capabilities, right? How to make sure that these are vetted, tested, and continuously tested in operations properly, and and you need to think about the interdependency between providing machine learning models to deliver a certain capability, and then having a capability in your network as well that continuously tests that. And maybe here we can delve a little bit about AI, testing AI, and how can intelligent systems as well be provisioned in a way that it can make sure that other intelligent systems are bound in their behavior, they do not hallucinate, do not go overboard. We know their quirks and we know their pitfalls, and we detect those, and then we generate test cases for those, and the whole CI/CD cycle is kind of now intelligently driven as well. So there is an interesting separation of concern that is decomposable and that is emergent as a consequence of the fact that more and more networks will be deploying, interestingly, pre-trained models and models coming from third parties. So this is more how we look at it at a high level, given the status of the technology as we have it right now.
Yeah, absolutely. And I think that, you stress the fact you need to make sure it works.
Yeah.
Which, so sort of like really basic stuff, but I think that we really need to keep it in mind that not only everything works independently, every part of the decomposable system, and then everything works in concert at the end, because there is a concern that AI is going to require a lot of energy, a lot of effort, and it will. And you have a lot of data you have to go through, so you don't want to be doing it over and over again for every system. And so, that's it. We have a question from Chris, and I think that's might be in your domain here. So the question is, where should AI be best used in a network, or rather where it should not be used in a network at this time? And maybe you can sort of link it back to the decomposable or not decomposed option. It's like, how does that work for different use cases? And obviously that's a big question. But let's get started.
Absolutely. No. So I think it's a good question, and it talks to talks as well to the process of what's important. So the whole question is really where should AI best be used in a network, or rather where should it not be used in a network at this time? So looking at that, it's a twofold question. One of them is there areas where we should avoid trying to do this, and if so, why? And is there areas where we should definitely do it, and if so, why? And if you start with the one where we can give examples of where it should not be used and for what reason, and that is as well going to take us down the route of why the decomposable model may actually make sense. So one area that has been very interesting and very hot here for quite some time, especially in Europe for the last sort of 2 years, has been around energy savings in the radio access network. So this is an area which is very straightforward, very simple, and it's a matter of figuring out where in the network for each cell can I basically turn on certain energy saving parameters. So once again, it's a task where a human being can quite easily look at it, come up with what is the right settings based upon a certain sort of forecasted behavior. And you can do that relatively easily for 1 or 2 or 10 cells. But when the network consists of thousands of cells or tens of thousands or even 100,000s of cells, then it becomes rather impossible for a human to do it. So it's very easy to say, okay, this suits itself for an AI to do this. And that is easily said, easily done. The problem you're starting to look at is my computational effort for doing this actually going to make this good ROI? So the amount of CPU I need in order to do the appropriate forecasting models, and that may only be deemed as ML, for example. So doing the appropriate forecasting model for each cell on the appropriate parameters for the next 12 hours, for the next 24 hours, etc., with enough high granularity so that I can then switch on the right energy saving features. That's going to consume a set of energy. The question here now is that energy consumed per cell higher or lower than what you're going to save? And if you're using this outcome here solely for the purpose of energy saving, you're probably getting to a point where you are very, very close to break even, or potentially you may actually spend too much energy computing the forecasting compared to what you're going to save if your network have a relatively high load as a starting point. Because then you're going to compute your forecasting for all of the network all of the time, but you're only going to yield when you're able to do energy savings. So net is this might actually turn out to be an energy loser if you don't do it well. If on the other hand, you're now doing forecasting for these cells to create, for example, an anomaly band, which you're going to use in your daily operations, then at that point you already have that forecasting done, and it's an obvious thing to reuse it in order to basically create this energy saving capabilities. When we're looking at a number of these things, it's easy to come up with a use case where I could use AI. The question is, am I going to be using, in this case, some decomposable capabilities where I'm going to get these functions out of other things I'm doing? Or if I'm computing something once, can I reuse it for many things? So in order to answer Chris' question here, the key is to understand, is there a business case in doing only this? And will I actually save money or save energy or whatever I'm looking at? And then you should really transfer all of these metrics into some simple and easy thing to do. Energy is a simple measure because you can easily compare that between systems and so on. So it's a simple and easy compare. But when you then start looking at it as well, AI may help you come up with answers that is very difficult for the organization to actuate. So at that point, doing it with AI and telling you 10,000 things you should change, well, it may be not really helpful either. Because as an organization, you can't take 10,000 changes and implementing them. But maybe you're just looking for the top 10 things you should do. So even if AI can tell you the top 10,000 things you should do, organizationally, you maybe have no opportunity to do it. So make sure that AI helps you execute the stuff that you as an organization can actually deliver upon, and not just give you higher burden on and add more stuff to the list of things you don't have organizational capability to execute with.
Absolutely.
To make sure it helps you rather than just giving you a bigger task list that you can't execute on and you just move a bottleneck.
Now, let's get to other use cases later, but I'd like to stay on this one for a little bit because this is like how can I say, a good sustainability and energy efficiency. It's a good way to kind of think about the broader issues that AI brings in. The question is like, if you use more power to run the model, then, but you could say that, if you train it well, and if you kind of, or maybe at the beginning when you train the model, when you're learning, you might use a lot of energy, but then in the long term that changes. But also, if you can reuse, as you said, if you can reuse whatever the model does can be reused by other tasks, then effectively, even if you run even on the energy efficiency, when you look at the bigger picture and you look at the overall energy consumption and all the tasks you can do, then your, the trade-offs are different.
Yeah. So absolutely. So let me give you an example. So we've been working a while with the RON and the RIC and the evolution of that. So some of the audience here might be aware of that we already decomposed our geolocation capability as an RApp, and that is using internally a number of machine learning and AI algorithms to come up with the location of the user. So in this case, we create the artifact that we deliver into the system is a geolocated event for the individual subscribers. So that can now be reused by all of the apps. So that's a delivered outcome. So the other apps don't have to compute the same location data multiple times. Similarly, you can come up with, for example, anomaly detection as a service, and that anomaly that you're now identifying can then be reused by all of the other sort of apps subscribing to this capability. So it's not only at the point where you're reusing specific models, but you are as well able to then reuse the artifacts delivered by these models through, for example, inferencing. But then obviously you may have a trained model that you're able to reuse and basically create leverage with. And we've seen, for example, national programs in various countries where they, for example, say all of the industry is going to unite to create a large language model trained on that local natural language. And then that large language model is going to be reused across all of the industries in that country. So that's obviously a way where they share the burden of the training of that in local language. No one else is going to do that. So therefore they do this, and that generates a model that they can then use freely themselves across those different stakeholders. There's discussions, as Takai said earlier, on the telco side to have the similar things unified between different operators. There's been some initiatives on the European side on that, and I think there's a couple of other ones coming along as well.
Yeah, absolutely. So let's just, again, before we go to the other use cases, which we'll get, but you raised an important other issue here, is the big models which are less domain specific, and then you get all the way down to models that are really domain specific, that really, so there is the language model might be tied to a different country, and then other models that might be so domain specific that are really just for an operator or just for a part of the network. So Takai, can you comment on it? So one thing is that, should operators develop their own models? Should they use public models? Should they use vendor models, or any combination of that? And how should we think about that?
Yes, I think as per maybe tried to say earlier, whatever makes business sense. So I think that's kind of what we should always say, whatever makes business sense, because it is a bit complicated to do this calculation and make a single recommendation for all. There is nothing that, no single advice or choice that would fit everybody. It's an interesting, there are an interesting set of parameters at play here. There is obviously an advantage if you go with one of the open source, for example, you're talking about Gen AI, to go with one of the open source models. You're reducing the cost of training your own models. You are relying on the fact that these were trained on, all of this unstructured data of the web. You tolerate some of the maybe bias or some of the issues that come as a consequence of that, and you try to engineer internally and devise and have that overhead of engineering an actual implementation that solves your own business problem. But you have at least saved all of that money that would have been required if you trained your own. In other cases, maybe that's not acceptable, because maybe in other cases you would require a great deal of focus and a great deal of reliability in the output of a particular model, and maybe the open source stuff will not be able to deliver that, right? And in many cases, they cannot deliver that. We know that across the board, most open source large language models fall short from the performance of, you know, their closed source counterparts. So there is an argument there in maybe dreaming of having something more specific, but then the cost there is tremendous. To be honest, at this time, I would be surprised to hear about a telco operator, for example, if you talk about them, find a business case to start from scratch this journey of building a large language model. But I would understand if the choice is made maybe to go with, you know, to partner with providers of such models, you know, to, you know, just, you know, delegate that overhead, not to the open source community, maybe to more specialized third-party providers who can maybe take that cost through some meaningful business model, right? So, but yeah, I mean, but ultimately it's about the business, because what exactly you're going to do. You obviously cannot just justify millions of dollars of investment for a co-pilot or a chat assistant, right? I mean, maybe somebody would, but I can't think of somebody who would. But if you have a really disruptive use case that brings you money, I don't know, generative use case generations, or maybe anomaly detection that can be explained through interactive agent, maybe ways to incorporate human feedback in your AI systems through user-generated models. Maybe one of these use cases could bring sizable ROI so that you could justify the initial investment. But these are not emerging yet as clear winners, in my opinion, and there is still time for us to figure out if these are actually winners. Yeah.
Absolutely. And I guess that the question there is that if you have a large model, it's very expensive to develop, but then the large model is not necessarily what you need, because it's, you know, in a network, there is a lot of data, but it's not as much data as there is in the whole internet, the old world out there, like the ChatGPT kind of data that you'd get. And so it's really important that and this is something that we discussed earlier in other Sparring Partners, is the fact that you need to cleanse your data. You need to have good data, because if the data is bad, there's no way that you're going to get a good model.
It's very difficult, yeah. It's difficult, costly, and indeed, as you said earlier as well, you don't necessarily, and I agree with you totally, and I would say in most cases, we still do not require Gen AI or large language models to bring value through AI. Architecting, putting together the right architecture, the right data foundation, and the right system level architecture for how you deploy and orchestrate these, whatever models you have, I think that's the key, is right there for the differentiation and building solutions that the telco industry can actually benefit from. And large language models are just a component, okay? They obviously have their place and will have their place for the foreseeable future, but they are part of a larger system that needs to be well architected, in my opinion.
Yeah. And let's as well be clear that in the area of the RIC for the all-round architecture, and as well what is being brought into the wider 3GPP framework here quite soon as well, inside that framework, VIAVI is one of the companies that is providing a tool that allows you to generate this training data. Absolutely, so with our what's called the RIC tester, we're able to generate any type of training data needed for basically testing out these apps. So that is evolving in how you can then move from a current network with the current operational model, validating how you can now build these new apps, the R apps and X apps that's going to control the new one, and then helping you then train those in both what looks like your existing network, and then as well what's going to looking at the future network scenarios. So what Takai outlined before of this data challenge, in areas such as for the RIC, this is an area where we looked at that it's going to be so many app developers needing this, that there's a mature market to basically go and serve that. Yep. When you then start looking at the general telco service assurance cases, we don't yet have those things happening. So you don't have anyone that can sell you or provide you a sort of, give me a network scale traffic generator that simulates me all of the possible northbound, eastbound, westbound interfaces that a network could provide up to an OSS BSS, so that I could train a model of that and get that in a fully coordinated end-to-end manner. And given that is where we then end up to what Takai spoke about, is that there's a necessity of figuring out, how do I get some of that data? How do I build my data assets? How do I build my data assets so I have the right labeling on it, so I can start using those labels appropriately to deal with it? So it's a whole big landscape, and when you realize all of that, that is why it becomes even more important that once you have established that in a good way, that you're reusing it. Because you can't establish that 5 times within an operator and then, drive 5 different development teams with 5 different data maturity projects and data gathering projects.
Yeah, and one thing I just want to add there is that as we have been a bit discussing this thing about automation and how far can we go with that, and wrapping this hype and looking at what actually is there in terms of actual useful long-term capabilities. I think one thing that I believe has proven to be a revelation and something that we'll use to address this automation gradually is the whole notion of incorporating human in the loop in an automated system. This has always been a challenge. It's part of reducing costs. It's about freeing a human being to do other creative stuff, innovative stuff, and do all other more important tasks rather than the mundane day-to-day maintaining of the network. Things such as reinforcement learning with the human feedback, active learning, all of these paradigms that have emerged through the need of generating data for large language models. Ironically enough, it's the process that has emerged as a very fundamental and reusable component, and that is what automation needs, not the fact that we just need to imagine a generic, all-knowing large language model that finally can move the levers and drive my network to success. That's not what's going to happen. What's going to happen is that an automated network through well-architected systems, solid data foundation, and the need to have a human in the loop. That human in the loop, to a certain acceptable level, needs the way it provides its feedback to the automated system. That in itself is an automated piece. That in itself can leverage data-driven processes. Reinforcement learning and human feedback, again, is a very interesting technique that has emerged. We knew about active learning in the past from other AI domains. So for me, it's like these kind of an interesting aspects that solve very specific yet fundamental issues that we always have in these discussions about automation, that will prove themselves to be fundamental and disruptive and actually enabling for actual real world benefits.
Yeah. Now, I have a question for you, Taki, but before I forget, I have one for Per, and you mentioned about generating data. Okay, so So there are 2 things, the data that you already have, and then the data you need to generate in order to basically test different scenarios or different, whatever you're doing, which is like, I guess it's a digital twin type of approach, right? So how do you go about generating this data? Is it, network specific, or is it just sort of a general set of data? I mean, how do you go about generating it? It's like synthetic data. How do you decide what's the good? Because again, you need to have good generated data, otherwise you're not going anywhere.
So I think the answer to this question is that it's as complicated to define how you do it as getting it right, because doing it requires you to fully understand what you try to model and what you want, and the future state of the network you're trying to build. So if someone is able to fully define, for example, how does that future sliced network look like, and where I'm going to have the whatever iPhone 20 and I'm going to have whatever other things out there, at that point in time, if you can define that well enough today, we can relatively well define a model that matches that. That is one way. The other one is instead to say, actually, I want to be able to generate a model, and I want that model to then have enough variations in it to give me a range of different scenarios And I can then test my applications and test my capabilities across a wide range of environments. That is really then allowing you to, I mean, not only base it on what you're able to define, but as well base it upon what you're capable of sort of, I should put it, you're using a little bit of brute force to avoid making mistakes in what you're defining because you define it too narrow. And that brute force gives you, I mean, you pay a little bit more in computational cost, but you are avoiding that the human is making mistakes in defining what it wants. So that is one way. The other way is then to look at other things like, how am I able to make sure that the data I have is appropriately labeled, and I'm actually reusing my existing organization, human in loop and otherwise, in order to get that label. And we use this in customer care for a long time. Every time you call customer care, after you're done, you get a question. How much did you love this interaction between a scale of 1 to 5 or 0 to 5 or whatever? And I mean, that was labeling. How happy are you after this? And all of those transactions, which we trained our consumers to basically give us, that is labels that goes into training the data. Now the question is, how do we make sure that we create other similar procedures in the network to generate this? There is things, I mean, once you close down a Teams call, there is always popping up, how good do you think this quality was? That's exactly for the same reasons. So as we are now working across this industry, how do we start collecting the training data needed for the future state of automation?
Absolutely.
And that's a strategic capability you as an organization build in order to do that.
Yeah, and I guess that sort of expands the concept of decomposable AI. So you have to decompose and reuse, but also you have to put it in a bigger context of whatever you're doing and make sure you do it well, which goes back to what Takai was talking about. It's like, you know, the human in the loop kind of issue, but it's like, it's not just the human in this loop, it's like everything in the loop, right? So it's the different, taking the different models, the different parts of the organization, and the different individuals, so the humans part. So it's a model, human, organization, and that brings into all issues of cultural change that we need to have. And it's not just operators, it's vendors as well. So maybe Takai, you can comment on that. You know, what is that we need there, and do we have it? Are operators and vendors ready to go for that cultural change, or what's going on here?
Yeah, that's an interesting question. I don't want to upset many people, but yeah, I'll try. I mean, it's interesting. Yeah, so we definitely have an issue, I think, in the telecom industry, and then I think it's for good reasons. Ultimately, is being cautious, overly skeptical, and sometimes a bit paranoid about just putting all of these, cool new things in my network, and they're moving, changing things left and right, and who knows what's going to happen. And that's true. Who knows what's going to happen? And the bad things could happen. So there is some serious risk, documented, well understood risk by now in deploying systems and models that were trained with large amounts of data to work autonomously. There are some serious documented risks there, and there are some funny anecdotes in the automotive industry about there were cars moving left and right and hitting pedestrians instead of following the road, right? So that comes from the right place, but nevertheless, if we are serious and we really want to move forward in this automation and the need to move seriously towards more and more automation is there. I mean, networks are getting more and more complex, more and more subscribers, more and more interconnected objects. We're going to have higher degrees of automation for us to make sense and actually extract business value from these networks, right? So we're going to have to go there. Hence, as a consequence, we're going to have to do the necessary cultural change. We're going to have to do the necessarily internal introspection, I guess, in a way, to understand that if you, as a company who wants to build machine learning systems to do some form of an automation, you're going to have to leverage your internal subject matter expertise in a way, right? And if you want to leverage that in a scalable manner, you're going to have to set up maybe some kind of an organizational change. You're going to maybe set up roles, maybe kind of incorporate systems that allow you to capture that subject matter expertise in automated fashion. And these are systems that have to be deployed, and expertise that needs to be hired, and R&D directors that need to be trained or changed or whatever, right? So these are things that they're gonna just have to happen, right? And only, I think, for the forward looking and the courageous companies that have strategic vision, I think definitely have this in mind and understand this. And I think there are some interesting things happening in the industry in this direction. And as a company, we perceive ourselves as going into this journey internally, but also playing this kind of interesting enabler for other companies to have this transformation internally as well. Have been able to collect the right amount of data from your network, have the right deep level of observability across your network elements, build in the right topological representation of your network. This will ultimately allow you to transform a lot of your network operations intelligently in a manner that is scalable and that delivers your business value, right? So it's a journey, and it's very interesting because it has these two facets. That it's in one element is an internal journey that any company that delivers AI or wants to deliver AI-driven value has to go through internally, and at the same time, there is this interdependency where a company like VIAVI Solutions can actually be facilitator and enabler for other companies, larger companies maybe, to go through their own transformations with regard to their customers and how they deliver value to their customers, right?
Yeah, absolutely. I see part that you, maybe you can tell us a little bit more, since you spend, I think, more time with your clients to see, you know, what is it you're hearing out there?
Well, I mean, so I think, I mean, what clients are going through is really what Takai spoke about earlier in the first part of this, which is that we have peak hype cycle. So in the peak hype cycle, people do what they have to do because the organization is asking them to sort of immediately do X, Y, and Z, because board is asking for things, senior executive management is asking for things, etc. So right now, teams are busy to fulfill what's happening in the hype cycle. But when you speak to them, I wouldn't use a word off the record, but when you're speaking to people in an authentic discussion, everyone acknowledges that, yes, I'm doing this, it's going to give us some decision data, but I'm doing this because the organization needs to respond and needs to be seen as visible in this space. We are seeing value, but that value needs to now be translated across the organization. Some of this value needs big organizational change, and no, we're not capable of doing that big organizational change right now. So based upon that, this peak hype is now, I mean, now people do AI because of AI, or they do Gen AI because it's Gen AI, not necessarily because it is what they need at this point in time. What's changing is people will do many more of the things they need in the next steps, and less just because it is Gen AI or AI for that matter. So they will do Gen AI, but because it is needed, not because it is Gen AI, if you get my point.
Yep. Yeah.
Yeah, I guess we need to have sort of a deeper awareness of how does that fit. You know, again, it shouldn't just be a mandate. It should be like, do we need, I mean, or it is a mandate to assess and to decide what to do, but it's not just you buy it and you plug it in. That's not happening. Anyway, we don't have much time left, so if there is any more questions, please go ahead and ask them. But I want to go back to the use case issue, because again, when we talk about pragmatic use, so the question is what for? And we went through some of them, but maybe we can sort of summarize. So we talked about energy efficiency. What else is the low-hanging fruit, and what else is actually something that might come up but not yet there? I don't know. Per, do you want to go first?
So there are obvious things which is coming from basically the need to drive automation. As part of the automation journey, there is a clear need of being able to do anomaly detection, being able to do automated root cause analysis, and then being able to do, appropriate appropriate modeling of what is the forecasting for these functions or services or nodes or whatever, so I can start moving into a predictive area rather than just reactive. So those would be the basic things that basically fit into this, and then the expansion of that would basically be Gen AI to be able to articulate intent as you're communicating between one function to the other function.
Yes. Takai, do you want to add anything to that? Is it?
Yeah. I think the journey towards automation and more of it is definitely a generator of a lot of use cases, and some of which Per just mentioned: root cause analysis, event detection, correlation, causal inference. These are all interesting, right? And they are valuable, and it's time for them to be delivered. In addition, new use cases that have emerged from recent trends in the telecommunication industry that I think also are possible and are slightly more interesting as well. As Per said earlier, talked a little bit about the disaggregated Open RAN vision, right? And the ecosystem of multiple apps coming from different places and have to end-to-end deliver value. There are problems of conflicts arising from this joint behavior of these different entities, and how to mitigate this conflict, right? There is the question of how to make sure that there is a reliable CI/CD cycle that ensures that these data-driven systems will always deliver value, not only when they are tested in the acceptance testing process, right? They're going to have to continuously and always and forever basically deliver value. So there's that question of that continuous testing element, right? And what to do about that. So, and we think we know a thing or two about how to address that through adversarial learning and maybe more, let's say, digital twin-based use cases, et cetera, et cetera. So these are also very nice new frameworks and where you could deploy AI ML in a very specific value generating use cases. There is, and obviously it emerges as a consequence, this whole discussion that we believe in VIAVI's AI, testing AI, which basically boils down to saying, you have AI systems deploying that will be deployed at scale in various forms, such as our apps and X apps on the RIC and the Open RAN architecture. You need a scalable system to ensure that it always function. And this scalable system that can ensure that they always function, and the data that it generates to do that, and to generate the test case and test procedure to do that, this is a system that can be driven by AI. And then can be an intelligent system as well. So comes, the very nice AI testing AI concept. So I think also these are nice new emerging use cases that I think the market already expressed the need for them to be fulfilled. There are other use cases that I think Gen AI also has triggered, but we need to be careful. I mean, and we talked a lot about that throughout the conversation here today. But there are still maybe having chatbots, chat assistants, improving customer service. These are always nice to have, right? These are always nice to have, and we will see what the industry comes with in terms of cost distribution and cost dynamics that would, make them happen, and why not, right? But the more fundamentals are the ones related more to automation and ensuring that the systems will function reliably, and the customers are satisfied, and cost of operating these networks is reduced. I think that's what the most of the value is. Yeah.
Now,
let me just add one last point to this. So one of the reasons here to as well look at how you can establish these platforms and capabilities, and how you can as well have call it self-governance of it, is that many operators today run on the regulated environment, which means that they may have license requirements for their 5G SA licenses and others. That means that they are not able to use cloud services from the hyperscalers. And it means that even if hyperscalers offers fantastic capabilities, it doesn't mean they will be able to use them for especially some of the network deep stuff. Indeed, and based upon that, you need to really look at how do I define the right landscape landscape so I can deploy it and use it in my environment, which might be tightly regulated from security reasons. So based upon that, there is really a need to think this through so that you don't have a perfect thing that relies on a extremely good function from a Google or an Amazon or an Azure, which unfortunately wouldn't make sense or possible to deliver in your environment.
But also, there is also a bigger issue that even if by regulatory reason you can use it, you might not want to use it because you don't want to. I mean, you want to avoid the lock-in. I mean, you know, we were working all that.
Absolutely. So the lock-in can be dealt with in many ways. But what is happening is obviously that certain operators is making very strong commitments to certain hyperscalers, and at that point you obviously need to use whatever you get access to in the most efficient manner. So the key here is that there is not one size fits all or one blueprint that delivers for everyone, but it has to be the right one for each individual organization, and making sure that it takes care of their use cases.
Yeah. You wanted to add something to that?
Yeah. So this lock-in thing, I think, is very interesting, and it has been illustrated quite strongly with this hype over Gen AI, because we are explicitly seeing these lock-in kind of trends also appearing. We can see the dominant place that some providers are play. And the fact that if you are going to train as we discussed earlier, if, for example, somebody makes a choice of training their own large language model, they will probably have to go into one of the hyperscalers or one of the large providers, and that creates that dependence on their ecosystem, on that GPU platform, or on that particular type of model. And so it's very interesting. I think long term, maybe this is not necessarily a good thing. I don't think, as Per said, there is one blueprint that fits all of how to deal with the danger of lock-in, but I think it is a danger that soon will be perceived by the telco industry, and they will probably come up with some solution to deal with it, because I think everybody will agree that it's not going to be sustainable in the long run for any given operator to be locked into one particular provider. That's going to be kind of, this is everything I think what the operators should be avoiding. So I think it's going to be very interesting to see how this will play out in the next actually 2 years.
So we're a little bit over the hour, but if you have a minute, I would like to ask you one more question, which is adversarial learning. It keeps coming up, but it's a kind of a new concept. So maybe you can tell us what is it you mean by that?
So I think this is it's like an undercurrent. I think at some point it received some attention, but then came AI and took everybody by storm. But I think what I mean by it is simply the idea that given an AI system that is doing something forecasting, anomaly detection, even Gen AI, right? How do you make sure that this system is resilient to particular types of input or failure modes? And how can you know what those failure modes are? How do you discover? How do you know that particular, given a Tesla car, if you show a picture of an apple, it will think it's a stop sign and then stop when it shouldn't stop, right? How do you know that particular input will make it fail? And how do you make sure that it ceases to fail given that particular input is at a very high level? And the process in which you would deal with the situation, discovering those failure modes and dealing with them, one particular way of approaching is adversarially. So it's a type of machine learning, is a type of learning, is a paradigm in which you devise a system and a process, basically sometimes an actual second machine learning model that goes into the process of adversarially testing the other system and their test to the point of discovering these failure modes and documenting them for you so that now you know where it fails. Yeah.
Okay, we are pretty much done, but I would like to give you the opportunity to leave to the audience your final words of wisdom. So as we move to a decomposable AI landscape, what is the most important thing that you think operators should do to get there?
Okay, let me take a stab at this. So first of all, you need to have an idea of what is the possible value you want to realize. Then through various experimentation, you need to prove that that value can technically be realized. So that means that you've proven the value. But now the question is going to be, what's going to be the impedance between you and implementing it? And that's what needs to be sorted out. And that could be organizational change. It could be a bunch of other things. And that's when you're then realizing, how do you get to realized value, and how that realized value is delivered in a sort of long-term viable manner. And if you don't do that journey right, you're going to end up in significant pain, either by having a solution that delivers interesting things but completely useless, or a solution that delivers real value but is really, really expensive to run, and you can't maybe continue to operate it even if it delivers interesting things. So I think Takai may have some very more technical, hardcore things, but that I think is important to listen to. But from high level, I think it's really important to understand the change management aspect of how we're going to use the output that you're delivering.
Yeah, change management is the key. I would say the same thing. I'll just add also, I mean, there are no shortcuts. So there is some serious work to do if we are to seriously embrace AML natively in an organization and as a core value generating element of the larger set of capabilities that any organization would have. There are some serious architectural, organizational changes and needs to be done, and new aspects need to be adopted, and there's no shortcut, and this has to be done. Yeah, that's how I would end it. Yeah.
Well, thank you so much for this realistic note here at the end. Thank you both, Taki and Per, and thank you all in the audience for participating. This was a great discussion. So thank you so much, and we'll see you next time.
Thanks.